Today we are going to finish 8M2 with lesson 16, applications of the Pythagorean Theorem. This lesson is the last lesson, again, in 8M2. You've learned a ton. You've learned about congruence. You've learned about translation. You've learned about rotation, reflection. You've learned about rules of triangles and exterior angles, interior angles, what happens when you cut parallel lines with transversals and the relationship between angles. You've learned how to prove the Pythagorean theorem. You've learned a little bit how to use it. In this lesson, we're just going to do a little bit more application of the Pythagorean theorem, and then you should be all ready for your test. Let me know if you need any more help. If anything in this whole unit didn't make sense to you, leave me a note on YouTube, on the YouTube comments, and I will make another video. I can make test help. I can do whatever you need so that you're going to be successful in 8M2 before we get you tested on 8M2 with your teacher and then move you on to 8M3. So let me know. I'm here. Okay, let's move on. We're just going to let you know a little bit about, there's nothing really new in lesson 16. Lesson 16, let's just take, really there is nothing new. There's no new learning. So pretty much the Pythagorean theorem is all about a squared plus b squared equals c squared in right triangles. That's the whole idea. So if this, so this is our right angle. Right angle is 90 degrees. 90 degrees, and that means that C. This is our C is also called the hypotenuse, and that is opposite our 90-degree angle. These are called What are these called? These are called legs. These touch. These are included. The 90-degree angle is the included angle. The legs are the sides that touch the right angle. Right. That's pretty much the whole idea of the Pythagorean theorem. Now, the key here is that a squared plus b squared equals c squared. So let's look at a few examples of this triangle. So if we can take this triangle, make a copy of it, and kind of move it over here, we can look and we can see what happens when we assign some lengths to these sides. So if we have a triangle here, and we remember if we had a 3-4 triangle like this, the two legs are 3 and 4, and we want to find out what the long side is, then we simply say 3 squared plus 4 squared equals, c squared, because this is A, this is A, this is B, and this unknown is C. And so then you get 9 plus 16 equals c squared, 25 equals c squared. And we know that the number squared to give you 25, which is c, must be equal to 5. It's also called taking the square root of 25. It's asking the question, what times what is 25? That's what this square root symbol means. What times what equals 25? And that's 5. So c equals 5, and then we can box our answer. Now, we also can use this a little bit differently, because sometimes we will know wait, what happened? Let's put our triangle here. And let's say we know, let's pretend this side is 6 and this side is 10, and we know this is a right angle, and we want to know now what this side is. Well, in this case, we know this is A, B equals, we don't know, and C equals 10. So the formula is going to look exactly the same, but the way we utilize it is going to be different. So in this case, we say, well, A squared, we write our formula down, plus B squared equals C squared. And well, A is 6, so that's 6 squared. We don't know what B squared is, or what B is. And then C squared is 10 squared. So here we go, 36 plus B squared equals 100. Well, now we got to subtract 36 from both sides, and we get B squared equals 64. And we say, well, what number squared is 64? And we say, well, that's 8. So we know that B equals 8. And we've utilized the Pythagorean theorem. So you don't always just get these two numbers. Sometimes you get this number and this number given to you, and then you got to find out this number. And we can just use our algebra to isolate, isolate for that number squared, and then we can solve. So we're just going to do some problems like that today. So we're going to do about 3 more. This is everything here becomes, well, let's move along. We're going to duplicate this one, come here. And everything from now on is pretty much homework help. We're going to call this homework help. These problems are all like ones you're going to see in your lesson. So or in your problem set. So let's make a triangle here. And this is everything we're dealing with is pretty much right angles. So notice your teacher may give you a triangle that doesn't have a right angle on a test. And if they do, they may be trying to trick you. But notice, if it's not a right angle, you cannot use the Pythagorean theorem. Pythagorean theorem, only works in right triangles. So here, let's use this example. 13. The long side is 13, and this leg is 12, and we want to know what this side is. Okay, what is that side? All right, so why don't you pause and try and see if you can. It's like the last one. It's like the last problem that we did. And so remember, you're going to need A squared plus B squared equals C squared. Now you need to identify which is which, and then solve for it. I'll let you pause and try. So hopefully you're going for it. You're trying this problem. You're not just watching me talk, because trying it is going to be the thing where you learn. You learn when you try and make mistakes, and then you either succeed or you make a mistake. That's going to be where your learning comes in. So let's go here and let's go in blue, and let's say, well, we're going to call this. You want to call this question mark A or B? This can be A and this can be B, or this can be B and this can be A. But this is always C, because this is the side opposite the right angle. So this must be C. So we're going to write 13 squared, and let's just pretend we call this one B and this one A. So A squared, which we don't know, plus B squared equals C squared. So let's square these numbers and solve as best we can. Subtract 144 from both sides. Keep simplifying, and we get A squared equals 25. This is working out nicely. And now we get A equals, what number squared? What number times itself? So this is A times A equals 25. What number does that have to be? That has to be 5. A has got to be 5. So in this case, this length is 5. Good. All right. Now, you may see this problem written a little bit differently. So let's go to a very common problem that you'll see often in geometry. And that's this one. Oh, look, we are on a coordinate plane. Look at this. We have a coordinate plane. And in this case, I'm going to ask you, what is A, B, and C? Well, C is easy to figure out. So the question is what is A, B, and C? Well, A is easy, right? Or let's say, here's our right angle. And now notice this is interesting because they've changed the letters around on you. This is A, this is C, and this is B. But we know, don't let this fool you. In this case, we know that it's this side squared plus this side squared equals this side squared. So in this case, we actually have A squared plus C squared equals B squared. Why? Because B is the hypotenuse. The hypotenuse. So don't let this fool you. So leg 1 squared plus leg 2, this is, this is a leg, and this is a leg. So let's look at the distances of these legs. Okay, so this leg is simply from here to here. We can just count that out. That's 1, 2, 3, 4, 5. So this is 5. So one leg is 5 squared, or 5. And this other leg, we can count this one out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this side is 12. Plus 12 squared, and we know about this triangle already, but we're going to solve it. This one we can't really count it because we don't know how far these ones are. So this is our kind of our unknown, but we can use the Pythagorean theorem to figure out how long the hypotenuse squared is. And so let's just call that, our that's B squared in this case. Now B is the hypotenuse. Don't let these letters fool you. Sometimes they're labeled in goofy ways. So we get 25 plus 144 equals B squared, and that's 169 equals B squared. And as we remember before, what times itself is 169, and that says that B equals 13. 13 times 13 equals 169. That's a good one to remember if you don't have that one remembered. Let's happy cat this guy. Good work. So sometimes we're going to see these applications on a coordinate plane. And the whole key when you're dealing with rectangles or triangles on a coordinate plane, again, is you're going to have, right angles at these corners. You will always be able to find distances from here, vertical lines and horizontal lines on the coordinate plane are really easy to figure out lengths. Horizontal on coordinate plane is easy to find horizontal and vertical distances. Let's cut over real quick to GeoGebra, and let's do another one. Let's just say, and I wasn't going to do this, but we'll set this up. Let's just say I want to find the distance of this line segment. So from here to here, I want to find out how far it is from A to B. Well, how can I do that? Well, I can't count along these distances. I can't count even numbers along a diagonal line, but watch what I can always do. I can always I can find the point that will make a right triangle. So that point will always be on a line. If you draw a horizontal line through one point and a vertical line through the other point, you can always find, watch what I do. I'm going to draw a horizontal or a vertical line through one point, and I'm going to draw, whoops, I'll fix this here. And I'm going to draw a horizontal line through the other point, and I can always make a right triangle. Look at that. Here's my right triangle. And now I can use my Pythagorean theorem, because I can find this distance, which is 3, and I can find this distance, which is 1, 2, 3, 4, 5, 6, 7. And now I can find my magic distance, which is 3 squared plus 7 squared equals d squared. And you can go about solving that problem and find out what d squared equals. Okay, we're going to go back to our sketch pad, do one more problem. And this one is actually appearing again. You know, this is more homework help. More homework help. And this says, this is a word problem. It says, I have a 20-foot ladder. I place it against a windowsill that is 16 feet from the ground. Right, so I have this house here, you know, a house, and there's this window, and I have this ladder that I'm going to place against. Let's just do the ladder here. So the ladder is like this, and it is 20 feet long, and this windowsill is 16 feet high. So the question is how far from the house is the bottom of the ladder? And we can answer this question. Think about it for a second, and I'm going to show you how we can solve this. And I'm going to draw the magic triangle for you. So pause and think about it. How are you going to solve this problem? And I'm telling you, the Pythagorean theorem can help you figure this out. Well, let's draw our triangle. I'm assuming you've thought about it. You've paused and you've thought about it. So here's our magic triangle. Ba-boom. Okay. So here's our right angle. So there is our hypotenuse. So our formula says that the legs, and this is our unknown distance, how far away from the bottom of the ladder it is the house. How far is this distance? Cool. Look at this use of the Pythagorean theorem. And so we get, well, let's do it in order. And we'll call this distance x. So the first leg squared plus the second leg squared equals the hypotenuse squared. So we get x squared plus 256 equals 400. So we're going to subtract 256. We're just now using our algebra, stuff that we learned last year. We get x squared equals 144. And so the question is x times x equals 144. What number, what times what number times what number is 144? Well, our answer is x is 12. And it's feet. Remember, we have to label our answer because it's a word problem. And we're going to put a little happy cat. We'll put some happy cats everywhere. And say, good work. Good work. Now let's go to the last problem. The last problem Okay, one more problem. And this is a problem that is, you know, we're not really doing square roots here, but I'm going to just write this one and kind of go over it real quick. I know that some of you your teacher hasn't really taught you the square root thing, and I kind of went over it last time, assuming you understood it. But let's just look at this differently. Let me just walk through the problem, and I'll tell you how you can write your answer if the square root thing doesn't make sense. So let's say this is 4, that's 1, and this side is x, and this is our right angle. So we know now that a squared plus b squared equals c squared. So we're going to call this a, we'll call this b. So x squared plus 1 squared equals 4 squared. So x squared plus 1 equals 16. Subtract 1, subtract 1. X squared equals 15. And so now the question is x times x equals 15. So x is what? Well, we know that 3 times 3 equals 9, and 4 times 4 equals 16. So the number times itself that equals 15 is between 3 and 4. You know, x is between 3 and 4. And we don't know what it is. And we don't have a way of calculating it. We don't have a way of finding what x is. You can, on your calculator, you can do this thing called square root. So you can say, you know, the square root, you can hit the square root button, and then you hit 15, and then you hit enter, and it will give you a number. Let me calculate it. Let me hit it on my calculator. I say square root 15, enter, and it gives me, you know, you hit this series of buttons here, and it gives you, you know, 3.87298 ... It keeps going. It's infinite. So what you say is, you say, well, you can either write it one of two ways. You can say, well, x squared equals 15, and say, stop there. If your teacher says to stop there, then you can stop there. Or your teacher may say, you know, teacher 1 may say this. Teacher 2 may say, well, write it like this. The number squared that equals 15, you write it like this. X equals the square root of 15. That means x is the number that, if you multiply it by itself, gives you 15. So one teacher may say this, one teacher may say this. But because you can't calculate it, one of these answers is the right one. Oh, and maybe teacher 3 may say use calculator. And so they may want you to say x is about equal to 3.87. About equal to 3.87. Yeah. Well, that's about. Okay, whatever. That's it. We're going to call it a day for 8M2. So unless, you know, unless you tell me that you need some help on 8M2 by giving me some comments on YouTube, or you know what? Let me just give you my email address. Let's go back here. You know, I haven't done this before, but I'll do this. My email address is cowboy.lipscomb@gmail.com. So if you send me an email and you say, Mr. Lipscomb, I need, you know, I need help with blah, whatever. You know, I need help understanding the Pythagorean theorem, or I need help with parallel lines that are cut by a transversal, or I need help with, you know, I don't understand translation, or I don't understand reflection, or where's GeoGebra? How do I upload GeoGebra, and how do I use that to study for my test? Or I just have struggle in general with studying for my test, or I need more sample problems. Whatever you need, you can either send me email to that email address and I'll answer it, or you can, more easy, just leave a comment on YouTube and I can then do it, I can answer it there. Or again, I can do a video, I can answer it straight in line through the comments. So good luck studying for your test. We'll hit ADEM 3 soon. That'll be the next video I put up, again, unless we do some more ADEM 2. And happy mathing. Enjoy your studying, and hopefully you're liking math. This is my favorite subject. I've always loved math. I've always loved helping out at math and talking about it and doing math problems. So, all right, enough of that. Oh, you're welcome. Good luck on your test.